Hey everybody, we're going to continue our study of section 1.8, inequalities, and another type that you might see is the nonlinear inequality as a quotient inequality. So say for example I ask you to solve x plus 3 over x minus 2 less than or equal to 0. So this is nonlinear just because you have a quotient. So how do we solve this? So we do the same way that we did the multiplication ones, the factoring ones. We find the values that make each factor 0, and then we do the test point method. Or you could do the number line method, but in this case it would be with division instead of multiplication. So you would want, in this case, the quotient to be negative. So less than 0 means we want the quotient, right, the division, to be negative, a negative number. So let's find, first of all, for x plus 3, what makes x plus 3 equal to 0? X plus 3 is equal to 0 when x is negative 3. What makes x minus 2 0? X minus 2 is 0 when x is equal to 2. And why am I saying equal to 0? 0 is sort of like my point of reference. So now we're going to do our number line, just like we did before, and I'm going to put my significant points in there. So negative 3 and positive 2. And as I put circles on them, are they going to be open or close, included or not included? So because we have the equals here, that means that x is allowed to be an endpoint. So for here, x is negative 3. Negative 3 plus 3 is 0. Negative 3 minus 2 is negative 5. So you're going to have 0 over negative 5, which is 0. And since you are allowed to be 0, negative 3 is going to be included. What about 2? Included or not included? Notice that x equals 2 makes the bottom 0. But if the bottom is 0, right, if you put 0 in for x, 0 plus 3 over, 2. If you put 2 in for x, you're going to have 2 plus 3, which is 5, and then 2 minus 2. So you're going to have 5 over 0, which is not allowed. This is actually undefined. Until you get to calculus, you'll actually get to see what that is. So this is undefined for now, so we are not going to include that. So x cannot be 2 because it's going to make it undefined. So we're going to have a solid circle and an open circle, just because x really can't be 2 because we can't have 0 in the denominator. And so now we have, similar to before, we have 3 regions, and that's because we have 2 factors. And so we want to see about the quotient. So we're going to do our test points, the test point method. So I'm going to have let x be something in the left will be something smaller than negative 3. So let's just say negative 5. Again, I'm just randomly picking a test point in that whole region. I can pick anything from negative 3 all the way to negative infinity. So I'm just choosing negative 5. And I'm plugging it into x plus 3, x minus 2. So I'm going to have negative 5 plus 3 over negative 5 minus 2. So that's negative 2 over negative 7. And just as before, the quantity, the value, doesn't really matter as much as the sign. Negative divided by negative is positive. So that means that on the left, we're going to have positive. Let's pick a test point in the middle. And again, be nice to yourself. Something between negative 3 and 2. 0 is nice, so I'm going to have 0 plus 3 over 0 minus 2. And this is going to be 3 over negative 2, which is negative. So that middle region is negative, the quotient, right, the division of these. And now a test point on our last region, the right. So pick something that is in this region, so something bigger than 2. So it can be 3, 4, 5, anything you want. So I'm going to pick 5. So I'm going to have 5 plus 2, right? X plus 2, x plus 3 over x, so 5 minus 2. So I get 8 over 3, which is positive. And so on that right region, it's positive. And so let's go back and see what was it that we were asked to find. We want the quotient to be negative. So negative means these are our test points for the quotient in each region. So negative would mean this middle region. And so we can write our solution. So now that we have it, we can say x is in the interval -3 to 2. And notice that one is solid and one is not. So how does that translate in our interval notation? So the solid circles become brackets and the open circles are parentheses. So this will be our answer. And again, you can do it with the number line method, but in this case, instead of doing the product of the number lines, you're going to be dividing the number line. Okay, so now we're going to just talk about what are the methods of solving this. So the steps, in solving this. So solving higher order inequalities, or I'm going to say nonlinear inequalities, just to include the quotient ones in there. So the first step is to make sure you have 0 on one side. So for example, if in this particular inequality from above I had x plus 3 over x minus 2 less than 1, right, I would want to bring the 1 over so that it is a 0. So we'll have x plus 3 over x minus 2 minus 1 less than 0. So that would ensure that I will have 0 on one side. Step 2 is to factor completely. So like the quadratic that we did in the previous video, you will want to factor completely. And with the quotient inequality, the trick will be to get a common denominator, or get common denominators. So in this particular example, right, I will get a common denominator here of, I will put a 1 underneath there, 1 over 1. So my LCD is x minus 2. So I would have x plus 3 over x minus 2 minus x minus 2 over x minus 2 less than 0. And simplify completely. So combine those. So we'll have x plus 3 minus x plus 2 over the same denominator. And so step 3 would be find zeros of each factor. And plot them in a number line. And plot on a number line. If you're taking notes, you could just, since I'm taking so long in writing, you could just screen capture this and attach it to your notebook. So plot on a number line. So here you would have, once you combine like terms for this example, right, you will have the x's cancel. So you have 5 over x minus 2. Oh, and sorry, it was less than or equal to 0. That was the original problem. So in this case, right, we will find the 0. So we will say x minus 2 is 0 when x is 2. Again, this is in the denominator though, so you won't include it. So it will always be anything from a denominator, it's always an open circle. And step 4 is you use test points. So use test points from each region to test the product or quotient. From each region, so however many regions you have, to find the product or quotient, depending on what kind of inequality you have. So in this case, right, my plotted point will be 2 on the number line, and then I will notice that in this case, because it's only one factor, it's only broken down into 2 regions. And this will be open. Even though this has an equals there, it doesn't matter because this comes from the denominator. And then you will pick a test point, something less than 2, something bigger than 2. So I will probably pick 0. Anytime I can pick 0, I'm going to pick it, because math with the 0 makes it easier to compute. And then something over here like 5 would work. And then the last thing will be write the solution in interval notation. And that will be how you solve a higher order or a nonlinear inequality. The other thing you might see in this section, or that you will see, not might, are compound inequalities. So what is a compound inequality? So a compound inequality is something like, say I want you to solve -3 less than or equal to 3x plus 7 less than 1/2. And I want you to solve for x. So notice that, so the reason this is compound is because you have two things. You have 3x plus 7, do you want it to be less than 1/2? And at the same time you want 3x plus 7 to be greater than or equal to -3. And so we solve this. With inequalities we still treat it as if it was an equation, except that with a compound now whatever I do to the middle, right, kind of like when we say whatever you do to one side you have to do to the other, except that here we have 3 portions. So whatever our goal is to get the x by itself in the middle. So I'm going to subtract 7 from everything. Can't really say both sides because I don't have 2 sides, I have more than 2. So I'm going to have 3x over here less than 1/2 minus 7 and greater than or equal to -10. And notice here that the one has an equals and the other one doesn't. So this is going to be an interesting interval because we're going to have a bracket and a parentheses. So now we divided by 3. Notice that in the previous step we subtracted. So subtraction doesn't affect the sign. Now I'm dividing. So anytime we divide, we should be a little bit careful. Oh, we need to simplify what that is. So let's do it here on the side. What's 1/2 minus 7? Get a common denominator, right? So you can write 7 as 7 over 1. So you have 1/2 minus 14/2, which is -13/2. So when I divide this by 3, I'm really dividing -13/2. So I'm going to have -10/3 is less than or equal to x less than -13/2 divided by 3. Now this 3, I'm going to write it as 3 over 1, so I can continue to simplify. Dividing by a fraction is the same thing as multiplying by the reciprocal of that fraction. So I can think as 3 over 1 as 1/3. That's the reciprocal. And so now we just simplify that. So I have -10/3 less than or equal to x less than -13/6. Right? With fractions, and when multiplying fractions, you do numerator times numerator, denominator times denominator. So this is my final answer. So the nice thing about a compound inequality like this is that it's very straightforward to go to interval notation because it's already telling me x is greater than or equal to -10/3, but it's less than -13/6. Since this has the equals, that means it's included. So it's going to be -10/3 and -13/6, and this one is not included, so it's a parentheses. And so that will be my solution for x.